So in this video, I'll spend a couple of minutes demoing Cashutube, and then I'll spend a lot more time going into more detail of how it works. So Cashutube is a system for watching videos and paying for them with Cashu. I assume you know what Cashu is. Now, you're probably watching this on YouTube, but I'll add a link to Cashutube so you can watch it there. And it's free to use, as we'll see in a moment. So this is the welcoming, the onboarding flow, telling you how to create a channel. So you select the server that you want to use. So this is a Blossom server. We'll go into more about that later. So this is the video server. You select the server and how you want to pay. Then you select one of the mints. This is the list of mints that are trusted by the server. And this is just a test mint, and that's convenient because it means it gives you the token for free. So in production use, you'd have to spend 10,000 satoshis here or whatever number of satoshis you selected. And but this is the test server, so it's for free. You get the tokens for free. So then we get a list of videos, and you can watch one of them. And it has all you would expect in a video player. You can do full screen. You can select the quality of the video, which by default the quality is selected automatically based on how the bandwidth is working. And there's these thumbnails along the bottom. So yeah, we're not here to talk about the video, I guess. You want to know about how to pay with Cashu. So I'll just pause this. So far, the server has paid, 102 Satoshis. Sorry, the player has paid this to the server. In this system, the player and the server don't trust each other. That's important. We don't want to send 10,000 Satoshis to the server and then have them like disappear and not give service. We want to give them very small payments as they are providing the service, as long as the service continues to be reliable. So the player and the server do have to trust the mint, of course. This is Cashu, we have to trust the mint, but we don't want the player to have to rely on trusting the server. So the player puts 10,000 Satoshis into the channel, creating a funding token worth 10,000 Satoshis. And both the player and the server now have a copy of that token, but neither party can spend the token on their own. It can be spent only with signatures from both parties. So that's a feature of Cashu is that we can lock tokens so that they're spendable only by certain parties with certain signatures. The Mint enforces all of this. And yeah, this is standard Cashu protocol. And so at this point, the player has signed a transaction that spends 102 of those Satoshis to the server and sends the remainder back to the video player. And then every time the player, multiple times per second, I think, the player is signing a new transaction and is sending the new signature to the video server, and then the server is validating that server side. So each of these payments has been made without any communication with the mint. So the player talked to the mint at the start. You saw that when the Lightning invoice came up. And then if at some point in the future we close the channel, then the player asks the server to close the channel. The server does that by going to the mint and doing the second swap. So the mint is involved only at the start when setting up the channel, and again when we decide to close the channel. It doesn't need to be involved for each micropayment, so that's why everything is really fast. So now what I'm going to do is set up a couple of small channels, and yeah, we now have two small channels, and I want to demonstrate that the system switches automatically from one channel to the next, and I should have made the channels smaller because I want to really exhaust this channel as soon as hurry up. Trying to force it to spin that channel quickly by hopping around multiple videos. This was faster earlier. Okay, just a few more seconds hopefully. Yeah. So 95 Satoshis. So this first channel is about to become exhausted and the system will automatically switch. Is that bad timing? Yes. Normally it's seamless. Yeah, switch to the next channel automatically. Okay, so I think that's enough for the basic intro, basic demo. So I'll go into a bit more detail. The server is a Blossom server, which is used a lot in Noster. So a Blossom server stores every file just with the indexed by the hash, the SHA-256 hash of the content of the file. So yeah, so this is a normal Blossom server, but I've modified it so that it requires a payment on for every request for a blob. So probably the best overall introduction at the moment in terms of writing is the cloud.md. So I'll put a link to this. Yeah, it gives the directory structure. There's two repositories here. So in the CDK repository, I forked it to add the Rust code that does all the channel operations. And then there's a Blossom server where I forked that and then added lots of stuff around payments, including the scripts for uploading the video. So yeah, this script will automatically upload a video in multiple different qualities and so on. So you just point it at your video file and it will do the rest automatically. This shows you how to clone the repository, check out the right channel, run the tests. Tells you about how, if you really want to look at the tests quickly to learn how the Rust code works, this is probably the right place to start. Read this first. But it'll point you at which of the tests are easiest to understand. Then we need a mint. So not any mint works because the SIGAL protocol changed recently. So this is what I'm using at the moment. I clone Nutshell, go to a particular version of it, make this small adjustment, then run it. Then you can check out the Blossom repository or my fork of it. Then check that out. Yeah, build it, then run the Blossom tests. So the Blossom tests are testing that the server, the Blossom tests take the place of a client and test that the server and also the mint do the right thing. So the Blossom tests have a lot of tests about the 402 errors, making sure that it correctly enforces payment and it returns the correct error message. Talking of error messages, actually, so if there's a problem with the payment, the server returns 402 payment required, the standard status code for that, with some details of what the server found was wrong. So an obvious one is invalid signature or insufficient balance. So the server keeps track of how much data it has served so far on this particular channel. So it knows what the balance should be, and it can yeah, tell the client that the balance was too small or the signature was invalid or that the channel has already been closed, stuff like that. And a bit about closing the channel. Yes, this is the cooperative close where the client asks the server to close. And then this talks about the server. This is a nice server that refuses to accept an overpayment. It closes cooperatively only at the exact right balance as expected. I already talked about Blossom. Oh yes, configuring the server. So here's where the server puts their private key. Yeah, because the server needs to know the private key. And the pricing, so per request, but also for the quantity of data. And we already mentioned that earlier, I think, that oh yeah, the Rust code in CDK is compiled to WebAssembly, because then the WebAssembly can be used in the player, which is JavaScript, and also in the server, which is JavaScript or TypeScript. So I don't know if there's an awful lot more I should add. Just skimming through this again. The tests. Yeah, there's a lot that's going to change. And oh, I should say a little bit about this pay to blinded pub key. So um, the the player and the server have their keys, their public keys, and the corresponding private key. But the mint doesn't ever see either of those two real keys. There's a lot of blinding that happens. It's like silent payments in Bitcoin. So yeah, this is specified in some detail, although this is actually a little bit out of date. But the idea is that for every proof where possible, we blind every proof differently. So then the mint can't tell that this is part of a channel. So even if the mint know that you and I have a channel between us, and even if the mint knows our public keys, the mint can't work out what our blinded public key would be. And this is blinded with a shared secret, which is based on the Diffie-Hellman. So this shared secret is used multiple times across this protocol for various reasons to add an extra bit of privacy. So here we use this will be updated soon so that the shared secret will be used to derive the ephemeral public key, which is used in this nut and so on. So I think, oh yeah, I might stop after I describe this. So the blob storage in Blossom, that's what Blossom does. There's this HLS video player. So these two things didn't support payments, but then I changed the Blossom server to enforce the payments using the WebAssembly code. And actually, I added this channel API. Oh yes, I'm uploading the video at the moment. What video am I uploading? Oh yeah, I'll cancel that. I modified the video server to have this register of the videos. So whenever you use the publish script, it will add this entry to the list of videos. I should also show the channel parameters. Yes. So the player asks the server for these details. So this is the pricing that we mentioned earlier. And this is where the server reports the key sets and units that it trusts. So then I think the last thing I'll show is there's a section on the WASM functions. Yes. So these started off as Rust code, but they're exposed to the browser and to the player by WebAssembly with all of these functions, so that then it's easy for the player and server to just call these functions. For example, as a function to verify that the signature is correct. So the server uses this function, and then the player uses this function to sign. So I'll stop there.